Okay, in this video lesson, we'll look at review of just factoring simple polynomials, mostly trinomials. So we'll first start with just a review of multiplying binomials. But to go even further, we'll look at something from grade school, just multiplying two-digit numbers. If you were given this example, first thing you would do is write it vertically. And as you begin to work this problem out, 2 times 3, 6, 2 times 2, 4, then you were told to put this placeholder. And some teachers say just put a little X, put a little something. Here, the reason why you're putting this 0 here is a placeholder because what you're about to do is multiply not by 1, but actually 10, because the 1 is in the tens column. So we're doing 10 times 3 is 30. The 3 goes in the tens column. Technically, 10 times 20 puts 2 in the hundreds column. Add everything up, 276. And if we look back before we go further, we actually performed the distributive property when we multiplied two digits times two digits. We distributed the 2. 2 times the 3, then 2 times the 2. Then we came in and distributed the 1. 1 times the 3, and the 1 times the 2. And by having this as the foundation, we could look at why we do what we do when we multiply binomials. We apply the distributive property, x times the x times the 3. What's different between what you did in elementary school and what you're doing now is, instead of having a ones, tens, and hundreds columns, we end up with a quadratic, a linear, and eventually a constant column. So when it's time to distribute the 4 times x, 4x, because 4x is linear, it makes sense to do just what we did before. Start a second row and begin to line up like terms. Distribute the 4 times 3, 12. 12 now goes in the constant term column. Just like in elementary school, combine like terms, end up with our response. So when we look at this and go backwards to help us set up factoring, we'll look at how things were put together. We realize that our constant term, 12, is the result of multiplying the 4 and the 3. And the linear term, specifically the coefficient of the linear term, 7, we got by putting the same two numbers together. We added the 4 and the 3. So with this as a foundation, we can begin to look at factoring this polynomial. We know that the 12 came from multiplying two numbers, and the 7 came from either adding or subtracting to get that 7. What I would like to present is a little bit more specific and less ambiguous way of finding our two numbers. My suggestion is to simply read the problem backwards. So if we read it backwards, the very first thing we get to is the 12. And so we know that the 12 is the result of multiplying two numbers. So I ask myself, what two numbers multiply to get 12? And if I continue to read backwards, the next thing I see is this symbol here. That lets us know what to say next. So we want two numbers that multiply to get 12 and also add. So that symbol lets us know that the two numbers will also add. Continue reading backwards to get 7. If I continue to read backwards, the next symbol will tell me something about the signs of those two numbers. As we go forward, I'll look at it a little closely. So the two numbers that multiply to get 12 and add to get 7 happen to be 4 and 3. Ultimately, my factors will be x plus 4 and x plus 3. Now the example. Again, the suggestion is to read it backwards. As I read backwards, first I get to the 21, not negative 21. I'm reading backwards. 21 comes first. So I ask myself, what two numbers multiply to get 21? As I read backwards, the next symbol will let me know the two numbers will also subtract. So there's less ambiguity, less uncertainness about, well, will they add or subtract? This symbol will tell you exactly the other operation. So they'll subtract to give the 4. Again, if I continue to read backwards, the next symbol gives me some information about the signs, which we'll talk about shortly. The two numbers that multiply to get 21 and subtract to get 4 happen to be 7 and 3. Our ultimate factors will be x plus 7 and x minus 3. So now we'll look a little closer. If I continue to read backwards, like I'm suggesting, we want to find two numbers that multiply to give 6, that will also add to get 5. And now here, this will tell me something about the signs. Here's what it'll do. Because you said add here, you will then say both. Because it says add, this lets you know that both symbols will be that sign, or both numbers, I should say, will be that sign. So this is the suggestion. If you're reading backwards and you actually happen to say add, guaranteed both numbers will be, in this case, positive. So which means then you could actually set up your answer. I know that I'm definitely going to have my x's, and both will be plus or both will be positive. The two numbers that multiply to get 6 and add to get 5 happen to be 3 and 2. My suggestion is when you place the two numbers, always put the larger one first. It's just a suggestion. So x plus 3 and x plus 2. Do another example. If I read backwards, first thing I get to is a 6. I ask what two numbers multiply to get 6. Next thing I see lets me know that the two numbers will also add, in this case, to get 5. Because, and again, the next symbol tells me something about the signs. Like before, because I said add, that lets me know both numbers will share that sign. So I can begin, so both will be, in this case, negative. I can set up my answer, both being negative. Now, my two numbers that I can multiply to get 6 and add to get 5 again are still 3 and 2. Recommendation is to place the larger number first. Again, it's just a recommendation. Another example. Reading backwards, what two numbers multiply to get 6? Reading backwards, and also subtract, in this case to get 5. Again, this will tell me something about the signs. Now, because you said subtract, that will let me know the larger number. Tells me, so I have to say larger. The larger will be that sign. My larger will be positive. So in essence, what you say here will give you something to say about the signs. Previously, if you said add, then both will be this sign. Now you're saying subtract, that means the larger will be that sign. So again, I could set up my answer. My recommendation is always putting the larger first. You said the larger was going to be positive. I put the positive first. So now, two numbers that multiply to get 6 and subtract to get 5 happen to be 6 and 1. 6 will go first, 1 will go second. So now I have a complete answer. One more example. Going backwards, what can I multiply to get 6? Subtract to get 5. And this tells me something about the signs. So because I said subtract, I will say larger. The larger in this case will be negative. So I can set up my two factors. Again, I put the larger first. The two numbers that multiply to get 6 and subtract to get 5 happen to be 6 and 1 again. So now in this case, the 6 is negative and the 1 is positive. So I have 4 different examples. So if I read these backwards, what I'm going to create now is an M statement or shorthand for the phrases we did on the previous slide. As I read backwards, I see the 6. I'm asking what two numbers multiply to get 6. So as a shorthand, the M stands for the multiplication part. Reading backwards is this symbol. There's the A to let me know that two numbers multiply to get 6 and add, in this case, to get 5. So I'm creating this little shorthand to come up with my two numbers. Because I said A, add, I'm writing B, both. So a device to kind of sort of help you recall. If I write an A, I'm putting a B, both. Both will be that symbol. My two numbers, again, I can set it up, both being negative. Set it up, 3 and 2 are my numbers. 3 goes there, 2 goes there. Again, I'm recommending the larger going first. So with the next one, M6, meaning what two numbers can I multiply to get 6? Next, a subtraction, so an S. What two numbers can I multiply to get 6? Subtract to get the 5. And because I said S as in subtract, I'm going to write larger. So the larger will be that symbol. So I can set up my answer. The larger I'm writing first, smaller second. The two numbers that multiply to get 6 and subtract to get 5 are 6 and 1. There's the 6, the larger number, the 1, the smaller. Next one. So M6, what did I multiply to get 6? We'll also add to get 5. And because I said A, B, both will be this sign. Write my answer, both having addition. The two numbers that multiply to get 6 and add to get 5 are 3 and 2. I typically put my larger number first. One more. What two numbers can I multiply to get 6? So M6, there's my S, there's my 5. Because I said S, I'm writing L, larger. Next symbol is the positive, so my larger is positive. Set up my answer with the larger first as a recommendation. The two numbers that multiply to get 6 and subtract to get 5 are 6 and 1. There's my 6, there's my 1. 4 more examples. So we're just going to go straight with the M. There's my M12, there's my A7. Because I said A, B, both will be negative. Set up my answer. The two numbers that multiply to get 12 and add to get 7 are 4 and 3. Place my larger one first as a recommendation. Next one, M20, S8. Because I said S, L, larger. The two, I can set up my answer. The larger will be positive. So I set it up. The two numbers that multiply to get 20 and subtract to get 8 are 10 and 2. I recommend putting the larger first, smaller second. Next one, M35, A12, AB, both. So both will be this sign. I can set up my answer, both being positive. The two numbers that multiply to get 35 and add to get 12 are 7 and 5. Recommending putting the larger first, even though it doesn't matter. Last one, M15, there's my S, 14. Because I said S, L, larger. So the larger will be negative. I can set up my answer, larger being negative. I'm putting that one first. The two numbers that multiply to get 15 and subtract to get 14 happen to be 15 and 1. Write my 15 first as a recommendation and the 1 second. So hopefully using this M statement will assist in factoring polynomials.